A company produces cylinders, which are made out of a stainless steel called SAE310S. The steel should contain 25% of chromium and 20% of nickel. This steel is used in environments where the temperature gets high. The height and radius of the cylinders is 0.5 meters. Each cylinder is divided into 5 layers. Then each layer is divided into 80 cells, whose size of most of them are 0.1 meter by 0.1 meter by 0.1 meter. To ensure the quality of the cylinders, the safety authority has set some rules. Also, the company has set some rules. If a cylinder gets checked, it means the destruction of it. So checking every cylinder would cost too much money. The company has 2 different types of electronic checking per day, namely destructive tests and non-destructive tests. For the non-destructive test, each day 10 cylinders are randomly chosen and their top and bottom layers are tested. Subsequently, within both the bottom and top layer, 10 randomly chosen cells are tested from the 80 cells it consists of. The destructive test also chooses 10 cylinders randomly each day. However, the next step differentiates a little from the non-destructive tests. Namely, the destructive test decomposes each cylinder into cells and randomly checks 20 cells. The destructive and non-destructive tests both examine 100 cylinders and 2,000 cells. Since the 100 cylinders used for the destructive test are replaced, a total of 10,000 cylinders are produced, which will take 10 days. Every single cell that violates requirement 1 will cost the company 1 million euros. If the total amount of cells violating requirement 2 is more than 5%, then the company will receive another fine of 1 million euros. We expected a relation between chromium and nickel after generating some plots. Since the regression line goes through all points in the figure, we will only consider nickel in our linear regression model, since we can express nickel using chromium and the other way around. We also found that around the middle of the disk, the percentage of nickel differed the most. For y bigger than 1 and y smaller than -1, nickel is more or less constant. Because of this, we can simplify our model where we will only consider data from y is 0, y is 1, and y is -1. Coming back to the fine, which we discussed earlier, we will estimate it by using a linear regression model using RStudio. Using our data and the LM function in R, we generated 3 plots. Furthermore, we used WLS, which stands for Weighted Least Squares Regression, to provide an approach to estimate, with the presence of non-constant variance. The intention is now to make figures for each level for Z in 0 to 4 and for Y from -1 to 1, and see which cells are at risk. However, we discovered that the only cells that need to be considered are found in Y is 0 and Z in 3 or 4. The others may be disregarded, since they will 100% agree with requirements 1 and 2. With the confidence interval used in the figure above, it is possible to find the mean and standard deviation of each individual cell. This yields a normal distribution and gives the probability of the percentage of nickel or chromium. By looking at the 95% confidence interval on all 4 cells, it is possible to determine the mean and the standard deviation. Finally, to calculate the expected fine, we use the probabilities to exceed R1 and R2. Using this, we can expect a fine. This results in a fine of 732,943.90. This is for R1. For R2, we have a 0 fine. So this makes a total of 732,943.90.